Right, let's look at some hyperbola and exponential past paper questions. I'm going to do one question per video, and I really encourage you to try them on your own. I'm going to write notes as I go along, but the hyperbola and exponential aren't nearly as complicated as the parabola, and we've already learned so many skills. So try each question on your own and then watch the answers. Okay, the first question says, given the hyperbola f of x, write down the equation of the asymptotes. Now, just a note to remember that hyperbolas have two asymptotes. They have a vertical asymptote, which is when x equals something, and they also have a horizontal asymptote, whereas when y equals something. Remember that an exponential only has a horizontal. Right, so let's have a look. I have moved this graph 1 unit left because of the plus, which means my vertical asymptote will be at x is equal to -1, and I've moved 3 units down, so my horizontal asymptote, which will be at y is equal to -3. Again, just to convince you why it's at x is equal to -1, when will x plus 1 equal 0? Because that's why a vertical asymptote occurs. It occurs because there's a value that x is not allowed to be. And I can very simply see if I'm -1 on both sides that when x is -1, I have that problem. So that's 2 very easy marks in an exam. Okay, moving on, write down the domain and range of f. Now, I haven't even drawn the function, and so some people would prefer to do the next question, which is sketch the function, and then come back. But let's just think about it. Every single hyperbola has a domain of x can be anything, and y can be anything, except there's one value that x can't be, and there's one value that y can't be. And basically, those are the asymptotes. X can't be equal to -1 because that's the asymptote, and y can't be equal to -3 because that's the asymptote. So when you've practiced enough of these questions, you get quite good at remembering that it's anything except the asymptotes in a hyperbola. Okay, the next question says, can we sketch it? Now, we've already done a little bit of work in trying to sketch it, and that we've already worked out our two asymptotes. So if I drew this, remember we don't draw to scale necessarily. So my asymptotes, let me just check. X is equal to -1. X is equal to -1. And y is equal to -3. Now I should be able to tell from my shape where my asymptotes are. My asymptotes, where my graphs are. This is a positive a value, which means that the two arms of my graph should be there and probably there. Unless it goes to the origin, in which case I'm going to have to redraw this. So what are we going to do? We're going to find our y-intercept. So I'm going to say let x be 0. So y, or f of 0, would be equal to 2 over 0 plus 1 minus 3. I think that's the right formula. Yes, it is. So I would put that in my calculator, but this is -1. So that over there is -1. Let me find my x-intercept. So I'm going to say let y be equal to 0. So 0 equals 2 over x plus 1 minus 3. So I'm going to put my 3 on the side. And then I'm going to multiply by x plus 1 on both sides. So it cancels on the right-hand side. And I get 3x plus 3 equals 2. 3x equals -1. X is equal to -1/3. So that over there is -1/3. Now, I do have a naked branch here, and so I do want to go sort that out. My naked branch, I'm going to say let x be equal to -2. So let x be equal to -2. I'd have y is equal to 2 over -2 plus 1 minus 3, which is -5. So -2, -5 is that the pointer on the naked branch. Okay, now that was with 4 marks. So quite quick, and remember I only marked the graph. So you don't actually have to do any of the working out very neatly. Okay, let's look at the next question. If f is translated 3 units right, now careful, let me just write down what f's equation was. F's equation was 2 over x plus 1 minus 3. If f is translated 3 units right and 2 units down to form h, what's the equation of h? Right, so who's h? H is a new graph, and I'm translating 3 units right, which means wherever you see x, I'm going to replace x with x minus 3, because I'm going 3 units right. So you'll notice the plus 1 is still there, but instead of writing x, I wrote x minus 3. Now, minus 3 was there in the equation already, but now I need to go further 2 units down. So I'm minus 2, which means if I neaten that up, it means that this new graph is 2 over x minus 3 plus 1, so that's x minus 2 minus 5. So again, 2 marks, so you can do that and just write down the answer, because there's one for moving it to the right and one for moving it downwards. Okay, next question says, use your graph. Really important. Remember, I've said this a lot. Never, ever, ever do an inequality actually algebraically. Always use your graph. So it says, use your graph to determine the values for x for which 2 over x plus 1 minus 3. Now, what is that? That seems familiar. Oh, wait, that's just f of x. So they're saying to me, when is f of x greater than or equal to minus 1? So if I go up to my graph, where is it greater than or equal to minus 1? Well, immediately I can see where it is equal to minus 1. It is equal to minus 1. The graph equals minus 1, so the y value is minus 1 over there at 0. So this is the point 0 minus 1. Now this question said, where is the graph greater than minus 1? So that would occur from that point there. That's the part of the graph which is greater than. All of this part of the graph and all of that part of the graph is less than this value of minus 1. So what it lands up being is they're talking about those x values from there to there. That's the part of the graph that lands up being greater than minus 1. Now just be careful, it said when is it greater than or equal to minus 1. So x must be less than or equal to 0. Because at 0 it equals minus 1. So I must be less than or equal to 0, but I must also be greater than my asymptote. I must still be greater than minus 1, because I don't want to go this side of the asymptote because the graph is below negative 3 there. So basically this lands up being one interval, the interval between negative 1 and 0. Now notice I cannot include an asymptote because the graph doesn't exist there. So it was specifically said greater than or equal to minus 1, but don't forget that that doesn't mean you can include an asymptote. The graph does not exist at that asymptote. Okay, now it says, find the value of c for which y is equal to negative x plus c is an axis of symmetry. Now we've done this quite a few times now. You do the method that you prefer and then check, but there's 2 different methods. Personally, I like to go and substitute in a point on the axis of symmetry. Now I know that a point on the axis of symmetry is the point of intersection of the 2 asymptotes, which here is negative 1, negative 3. Now notice I've only drawn in the negative sloping axis of symmetry because they said the negative sloping axis of symmetry. So personally, I would substitute in the point negative 1, negative 3, because that's the asymptote intersection point. So negative 3 equals negative 1 plus c. So negative 3 equals 1 plus c. And so c equals negative 4. So I know my equation is y is equal to negative x minus 4. Now the other way to do it would be to do the same transformation on the axis of symmetry. Your original axis of symmetry would be negative x. But this graph moved 1 unit left, 3 units down. So if I transform negative x, it becomes negative x minus 1 minus 3, which is negative x minus 4. And ultimately you get the same answer both ways. Okay, now that's a very classic hyperbola question. Should be fairly easy marks once we've practiced quite a lot. So that was question 1. Well done.